Hey everyone, how's it going? Welcome to the stream. So I'm actually feeling under the weather. You can maybe hear it in my voice. I'm a little congested. I almost didn't stream tonight, but I took a couple pills and decided to stream anyway. I'm not gonna last too long, I think, but I'm gonna stream because I won't be able to stream on Wednesday. Hey Pyro, how's it going? You managed to catch the stream when it happened. That's cool. So yeah, we'll see how far I can get tonight. But I still felt like coming online and just, you know, messing around a little bit, see if we can get somewhere. So last stream, the last thing that I looked at was we were messing around, trying different ROMs, and I happened to try Head Up Action Soccer, but the B1 version. Let's see. Heads Up here, this one here, and I had this via not implemented error. Yeah, you're actually on time. So I'm glad to have you here, Pyro. Yeah, so it says here that, you know, for Heads Up Action Soccer, it works. But this second version, the B1 version, I have a problem because in my VIA, there is, you know, I get this message that I wrote that there is a write to the interrupt enable register that's not yet supported, and it's for this interrupt flag for CB2. Now, I didn't like really look too deep in the docs for what that is, but I think I know what it is. So if we look here in my own VIA implementation, I have this comment here. It says shift register's CB2 line drives blank. So what I think this is basically there's an interrupt that gets raised whenever the shift register like ends up enabling the CB2 line. Which ends up, you know, triggering, I guess, an interrupt that says, oh, blank is on now. And so I'm gonna try and hook it up that way, and let's see if that actually let's see if that actually makes sense. So we'll do something like that. It's a bit cold in my basement. All right, so let's see, how do I do this? I'm going to do something, I guess, similar to how I did the CA1 enabled. So I have a CA1 enabled bool, and I have the CA1 interrupt flag. What did I do with this again? Okay, so that's the interrupt flag. It gets set here. So CA1 is set when joystick 2 is pressed, which is usually always for peripherals. Interrupt flag for CA1 is set when CA1 line goes from disabled to enabled and is cleared by read write. Okay. And the CA1 enabled here, I'm just tracking it because I need to know what the last value was. So I don't think I need it enabled for my shift register because the shift register knows when it was last enabled. So I think I can do this a bit more simply. So what was it again? Was it CB2? Yeah, CB2. Oh, I have a CB2 active. This is actually what I want. It's not the enabled. Set blank. This is confusing. Oh yeah, okay. Right. Okay, yes, I see. Okay, so we'll check what we want to detect the edge for blank going from disabled to enabled. So I don't have a getter for that, but we'll just add one, or I'll just call it blank enabled, like this. And then we'll say oh, actually I'll do it like this. CB2 prev. It's a bit of a hack, but it should be okay. And then we'll say, okay, if we were not enabled and we now are enabled or active, then this becomes true. Let's see here. Do I like this code? Alright, and now I need to reset this to false in certain places. So this is the one we're trying to handle here, CB2. So reading or writing port B IO. So similar to how we handle CA2, which is for port A, we got to do the same thing here for port B. For reading or writing, let's see. So CA1. So that's a port A cleared by right. So we'll, here it's up there. Cleared by read-write of port B. So we want to do the same thing down here. Okay, so clear interrupt flags for any bits that are enabled. Yes, so we're doing for CB2 now. So this we can remove. So shift CB2. Oops, shift CB2. So if test bits value interrupt flag CB2, just following the pattern here. We'll also clear it here. So that means we can remove this guy. And then here's the get interrupt flag. And I think that's it. So if we follow the CB interrupt, it starts off as starts off false, and Yeah, I should probably reset it as well. Don't I have a reset function? Oh, I never actually set those, did I? Yeah, I'm not doing that right. Okay, I need to do that. I have to also reset screen here. So let's see, port B, port A, data direction, B and A, perif control, and interrupt enable. So those are all handled. Then I have the screen, I have the timers. Yeah, I should totally be resetting these things. Can I do it this way? I mean, I haven't had any issues with reset yet, but I could easily have one. Let's see if this actually compiles. Alright, let's see if this does actually something. This has like a really long intro sequence for some reason. Come on. Hey, what's up, Lisp Gamer? I'm pretty good, you? 453. Did I not take that off? Four-day week, yeah, same. Yeah, okay. We now do handle this, so I can just take this off. What's Sea of Thieves? By the way, Lisp Gamer, it's my turn to be sick. It's a new rare game? Oh, really? 459. Yeah, this one here is always a bit annoying. Let me see if I can continue. Right to clear interrupt not yet supported. Did I not remove this one? 425. Oh, now it's CA2 that it wants. Yeah. You were the one who was sick before, eh? Is it good, by the way? This game? I'll have to check that out later. No, so still going into illegal instruction, eh? What's illegal instruction? Right off the bat. You have work in a few hours? Oh, Pyro does. Right. Okay, so we're in the BIOS right now. Hey, you wake up early, Pyro. Okay, so actually what I'm going to do is I'm going to I really need a reset instruction. Alright, so what I'm seeing is that there could be something wrong in this ROM. I just want to double check that, but it looks like something funky is going on here. Need a longer trace. Yes, that's right. This gamer and I go back a long ways. Hey, what's up, ABD? Not much. How you doing? I think I realized I should not be searching for just $0. The very fact that we're at 1 here. Yeah, I'll change my search. Oh, it was okay. It was $1 I was searching for. What about $0 here? So the beginning of line followed by a real square bracket, $, and then not F. That's right, $sign is end of line. So I don't have one yet. Okay, maybe we can go about this another way. $1DE3. $1DE3. Now we're at $1DE6. Yeah, so I haven't watched the videos, but I've definitely heard about it, and I know about Unity's IL to CPP. I listened to some podcast of one of the core devs at Unity, and he talked all about their IL to CPP. It sounds really cool, and yeah, and I've heard people talking about it at work, you know, where they're trying to go and their whole like data-driven thing, and how they have Mike Acton there now. Yeah. So Yeah, I've had a. You're saying I had 7 viewers. Like a few weeks ago, there was somebody actually posted like on Twitter, or no, sorry, it was on Hacker News, this link to this. I had shown it before there, but somebody has this curated list of dev streams. I think they call it awesome dev streams, and you know, one of my viewers was nice enough to add me to the list, and then this list was posted on Hacker News, and like within less than a week, I got like another 50 followers, which was pretty cool. So yeah, that was really nice. They are rewriting more of the system in C#, but they have access to the compilation tech as well. When you say they have access, who do you mean by they? Yeah, what I heard was stuff like, because they have this, you know, complete control over how, you know, what happens to the C# code, how it gets transformed to C++, right? They basically can now do all kinds of interesting things, like they can SIMD the code, they can make guarantees about, you know, how somebody was telling me that they can make guarantees about how they thread things, about what was it again? Making things deterministic. Yeah, I heard about that. Like they made their own kind of sub language, their own DSL that you can write in. It's like a way of declaring your data oriented structs of arrays and being able to iterate over them and stuff. Yeah, I read like little bits and pieces, I hear things, but I haven't like, you know, really dived into it and read more about it. I really should though. Yeah, I don't know. I don't know the details, but it's something like, you know, because all the code's going to go through IL to CPP, they can do all kinds of transformations and guarantees. A little bit like what Rust it does, you know, like how they can guarantee, you know, how ownership is transferred and stuff. I don't think they're doing exactly that, but it's like having a bit of a hand in the compiler. You know what I mean? But I think Unity is really cool. So 1D E6. Let me see here. 1D E3 was 0A 1A. So DE3 E4. This is 2 bytes. Why are we at 1DE6? Let me try and make this illegal instruction a bit better. Maybe it's the reason why we're 2 bytes ahead. Let's see, E3, E4. It must be a page 1 or page 2 instruction. PC, current instruction PC. A lot of threading stuff is in the custom vectors and maps. I'm pretty sure you could hack something together in C++ 11, 14, 17. They have a model for that, but I think they handle it at the library level. That sounds really interesting. Definitely have to check that out. Okay, that's it. It's because we read what's one DE5. E4, E3 and E4, then at 1DE5 we read an op. It's opcode 5 on page 0. Which is illegal. So I'm curious, does this ROM even run on another emulator? Maybe I'm just wasting my time. Let's see. Let's use vid VID. Right. Which makes sense. And when you say that they handle the custom math, I'm assuming that they also do, they're able to do their SIMD stuff, right? I mean, if you're going to generate the math code, you may as well generate vectorized code for the target you're targeting. Mm-hmm. Yeah, that makes sense actually. To be honest, it sounds like a super cool team, you know, like if I were working at Unity, I'd love to work on the IL to CPP team. It sounds super interesting. I love that kind of stuff. Let's see. So what do I want to look at? Oh yeah, I want to see if that other emulator, this one here, let's see if this guy handles this ROM. So you got all this by watching this video, Lisp Gamer? Aha. think this means it did not load it properly, but I'm not sure. Oh, maybe let's see. Oh no. So far so good. But you see how like the audio is all messed up? I think this ROM is messed. I'm really hoping this one fails, because then I don't have to work on this one. Well, I'm gonna consider that like a crash or something gone very wrong. I mean, I end up outputting errors and stuff like that, but if I made my emulator error proof, and just kind of skip ahead without logging or stopping, I think it would be similar. The fact that there's nothing rendering and when we hear this hissing in the audio, that's pretty revealing. And just for completion's sake, let's try the Vectrex emulator as well. Thanks for the link, this gamer. I'll definitely give it a watch later. So you guys can see this, yeah, Vectrex, there it is. Alright, let's try this. Okay, so I'm pretty convinced this ROM is messed up. I'm not gonna try spend any more time on this. Okay, well I guess that's good news, right? It's good news because there's not a bug in my emulator here. So I need to say I need a tag for this. Broken ROM. How about that? And I'll just say this ROM executes illegal instructions early on. Bad. So now I don't know if I should keep these changes. Like I went ahead and implemented something, but I can't validate if it's correct. Well, this I could keep, but this whole blank enabled stuff, I guess I should keep probably the reset code. But all this blank, this CB2 stuff, I don't even know. I don't know if any game actually relies on when. I don't know why any game would even care about when the blank gets enabled. Well, maybe. If you want to like start up a draw and you want to get interrupted when the draw is finished. Suppose that would be a use case for CB2. But again, I don't have a real game that uses it yet, so I can't validate that this implementation is right. So I'd rather not put this in. So I'll just put this, I'll stick this on a branch and I'll have it if ever we have a use case. I'll take all the code that doesn't touch this CB2 stuff. No, not that, not that, not that. Okay, so that's all CB2. This is just a reset stuff, so I'll take this. Via implement proper reset. And CPU better error message or illegal instruction. I'll update the compat later. Okay, so these three, I'm going to stick them on a branch. We'll say CB2 implementation, CB2 interrupt, implementation, CB2 interrupt there. And I'll just push this branch up so I have a backup on GitHub. So this is something I do a lot when I work, is I'll just push a whole bunch of branches of work in progress stuff. Excuse me. So yeah, like if you look here, I just have a bunch of branches: speed up glow render, no debugger, assert disabled, an optimization where I coalesce lines. Just stuff I try out and that I'm not sure yet if I want to keep, and then later on I might cherry pick those changes. This I should delete. Was it too loud? Okay, so let's check out master again. Hey, if I die on stream, at least you guys know that you guys could like call the cops or something. think I didn't push this last time. No, I should probably check that my reset even works. It's 911, dude. Like in the US. Alright, reset looks like it's working. Oh yeah? So Belgium 101. Oh really? That's funny. It's funny that movies would decide what number to use. That helicopter is really cool. I love how the tank has this like two-stage death. I guess that makes sense. Same thing happens here in Montreal. All the movies are dubbed to French. So, and the thing is, usually it's the French dubbing from France, but there's also the French dubbing for Quebec, which is not the same accent. This game is getting tough. So I don't think I'm supposed to be a tank. I think I'm supposed to be some kind of like armored jeep or something. And then these guys are tanks. And holy crap, these tanks move fast. Ah, crap. I have one Jeep left. That was a pretty good run. So, where are we? One thing I could work on is these couple of games that still have an unhandled op for SWI. Let me see what that would entail. So let me just try running this armor attack and seeing if we still get that error. This B1 version. Yeah, you should totally try it, Lisp Gamer. Hey, take it easy, Pyro. Thanks for hanging out. I know it's really late for you, so appreciate it. Yeah, Lisp Gamer, I said at the beginning of the stream that Wednesday I won't be able to stream, so it'll have to be next week. What was I saying? Yeah, I don't remember. Okay, so let's take a look at SWI. Software interrupt 1. There's also SWI 2 and SWI 3. It's an inherent 19 cycles, potentially 20. Okay. Interesting. So why is it real slow? The reason for SWI 2, SWI 3 is you switch to the supervisor stack. Huh. And I'll just copy this whole thing. Oh, that makes sense. No, that what you're saying makes a lot of sense. It's like, was it int 10 in DOS? Yeah. Yeah, nice way to basically run, execute like, you know, kernel or BIOS routines and continue where you left off. I'm guessing this is supposed to be 16-bit. I just stopped here because I'm like 18-bit operations, but then it says 16, so there are definitely spelling mistakes of all kinds in this book. So yeah, this for sure is wrong. That this should be set before. Just this is the same mistake that was made that I talked about a couple of streams ago. Yeah, where they were saying that like for IRQ that the I bit in the control codes is set after pushing the CC to the stack. So you see here CCR has pushed the stack, and then they say, and then set INF to mask interrupts. But if you do that, later on when you RTI to come back, then when it pops CCR, it won't Oh wait, is that right? No, maybe that is right. Hold on. I'm like getting myself confused here. It would always restore this flag set to 0. That's it. Alright, because if you want to receive an interrupt, you need to set it to 0. So yeah, and on RTI you want it to go back to 1 to be masked out again. So yeah, it should be the same thing. So I think this is wrong. This should happen before we push CCR. So I'll do the same. Actually, I don't know. In this specific case, this is not waiting for an interrupt. This is we generate an interrupt. Let me check the other book. Now switch section again. It's page 316. All right. Okay, so it doesn't talk about SWI here though. Oh no, it does, doesn't it? Following special instructions can be used to manipulate the 6809 interrupt system. SWI sets the entire flag, saves all the user registers in the hardware stack, and disables the regular and fast interrupts. It then places the contents of address FFFA and FFB in the program counter. SWI2 and SWI3 are similar except that they do not affect the interrupt masks, and they use different vector addresses. So maybe in the case of SWI, it will set the flags after. Does that make sense? I suppose it makes sense. Alright, so let me copy this here. The SWI software interrupt instructions produce almost exactly the same response as an interrupt signal, hence the name. The only difference is the locations from which the CPU obtains the new value of the program counter. SWI instructions are useful for debugging, see chapter 19, and for returning control to a monitor. There you go, Lisp gamer. Or operating system, while simultaneously saving the current state in the stack. SWI instructions are also referred to as traps, since they can be used to trap the microcomputer to special routines in the event of hardware errors or other unusual events. SWI is commonly used in packaged monitors and operating systems to transfer control from user to system. SWI2 is supposed to be available to the end user and hence should not be used in packaged system software. Alright, I think we have enough here to go on. We'll see how far I get in the next 30 minutes or so. So IRQ first, then FIRQ, and then we'll do SWI. I think we're gonna have to do something special here. Don't know. Put it here for now. I guess I don't really need, I don't need anything for OpsY. We might pass in 1, 2, or 3 or something later. So let's see here. FFFA and FFFB. I should really just fill in the vector table. I have the list somewhere. Where is it? Here. So SY3 is at FFF2. SY2. Fast heart, so this is IRQ. So we have IRQ, we have SY at A, we have NMI here. Okay. Alright, so here, come back to this Y over there, so we read that. I'm thinking maybe I'll do something like this. I want to turn this into an enum just so that I can do one little thing here. Let's see. Then I can go here and I can say interrupt vector type. We can do that here, and if the type is equal to only in that case do we mask these. Otherwise, do this. Oh, it's 2 and 3, not 1 and 2. Anyways. Three and 2, yeah. I don't know why I've written 1 and 2. Okay, so now so what I like about this is that we can pass in here which one we want. And we can actually implement SWI1 and SWI2 at the same time. So SWI2 is on page 1 at 0x3f, so same address. SWI2, I should say. And SWI3 is on page 2 at the same place. Alright, so we've got the 3 calls that we wanted. I don't think I need this anymore. I think I needed this when I had no other cases. Believe that to be right. Really? This is for your engine? Alright, so I think that's it. This should work. Let's see if armor attack B1 gets a little further now. Sounds cool, man. So you mean like you're kind of like writing an interpreter? Maybe a bytecode thing? Okay, so it looks like I got past the swipe, but now it looks like it wants to do a reset. I didn't really do a reset, did I? All right, here. Oh, like a big switch statement, yeah. It's funny because you can see the shape of my CPU here, and if you look at the shape, you can see this long, thin section here, which that's basically my massive switch statement here. And the only parts that are a little bit longer are the places where I deal with branching, because I use I like this. Basically, I have this op branch, and you give it a condition function, and I have this if the condition function, then set the program counter to jump by the offset, right? And the conditions are passed in as lambda expressions here, and then this gets completely compiled like out, and it just becomes this inline code. So it's kind of cute, So you can see right away the logic for branch greater than or equal checks negative and overflow, and branch less than checks negative and overflow as well, but in the opposite way. I kind of like that, it's very clear. Okay, so reset. Let me see what it says about this reset instruction. I'll check in this book first. Reset in caps. Yeah, pretty happy with this. Very functional style, right? Excuse me. Like, does reset simply reset? I suppose it does. Yeah, I mean, you see, right, that I'm using templates here? This is a template, the condition function. I don't know if that's what you meant, but I'm using templates everywhere here. It's like a combination of templates and const_expr. So this is a template function. This here, lookup CPU op, is a const_expr function. Oh no, actually it's not a const_expr. So I have a couple of const_expr things here. These are not const_expr functions. Well, I guess they are, yeah. I am using Visual Studio. It's 2017. Reset. Oh, so the code overview is really nice. It's in options and somewhere. Oh yeah, text editor. And then you have here display, and I think it's show, I don't know, it's one of these. I don't remember which one. Selection margin is probably the selection here. Indicator margin, highlight current line, show structural guide. No, that's these guides here. I don't know which one it is. It's one of these things. Some kind of preview thing. Oh wait, here. Scroll bars. Behavior. Use map mode for vertical scroll bar. And then here you can decide how large you want it. Like if I made it wide, it gets a little bit wider like that. And you can also go for narrow. Make it really... maybe I'll go for narrow. I'll just leave it alone. But yeah, I think usually it's use bar mode. It looks like this normally, right? You can say use map mode, and then it'll look like that. That's cute, you know, and you have this like preview so you can kind of get an idea for what's there. And what I like is these little, but I think that happens with the normal one, is that these little green marks that show where your cursor is, or yeah, the cursor is here and the green marks are where you've made modifications. So these are useful. All right, so reset. Let me see if I add a reset and just make it reset, will that do the trick? So let's try. I need to do something about these cycles here. Maybe I'll just put 0. So that would be 0x3e. I'll do this, op reset, and then I'll make it call reset. And I need to do something about, like I said, I'll just put 0, because 0 should line up with what I put for return from interrupt, and I think that will be okay. Alright. It's a lot of writes to invalid addresses, so not feeling it because we're going in the right place here. Let me just disable this one message just to see if we would get further. You're complaining about Unreal? Don't you have like a powerhouse machine? Oh, and I have an illegal instruction. Yeah, this is not boding well. So, I mean, one possibility is that this is a ROM that maybe relies on bank switching. I haven't looked at all of the bank switching stuff. I'm curious. Let's do the same test as earlier. Let's see if this ROM actually works in the VIDE emulator. Oh, whoops. Ah, okay. You're running Windows on it. You're having trouble with it. Okay. If this emulator is not running it, I'm gonna assume that it's another bad ROM. I don't get why I have all these bad ROMs. Maybe I'm wrong, but let me try, of course, with Vectrex. Our little dance that we do. I gotta remove all the... No, I'm gonna use my rename tool. Search for space, replace with underscore. All right. Vectrex. $19 gigs. Oof. Okay, so Vectrex does not run it either. You know, before I spend any time debugging any of these, I should just try to run them in these other emulators, especially VIDE. Broken, wrong. Okay, so just to see, we've got Fortress of Narzad B1 here, which also had an unhandled up. Let me try this one right away in the other emulators just to see. Fortress, so this one here, or did I kill it? I will have spent a whole stream working on stuff that's useless. All right. And I must No, I mean, it's okay, right? Like, in a way, it's kind of good because, like, it means I don't have bugs in my emulator. So I'll take that. So this one doesn't even get to the start screen. All right. And I guess it kind of makes sense that the only two ROMs that had this unhandled op SWI were these two, and these two seem to be busted. Hey, BD. So you're struggling on how to learn programming effectively, and I'm sick and tired of reading pages and not being able to make any programs. So you've been reading pages online, is that what you mean? Try to learn? Like, what exactly have you been reading? Are you trying to learn C++, is it? Because to be honest, you have a PDF of C primer. Okay, you're trying to learn C. So, I mean, I learned from books when I started. You know, I think that you need a really good book to get started. If you're really, really starting out, you need like an excellent book that's not just about language, but more about programming. You know, something that discusses what programming is all about, and describes the paradigms and the idioms behind programming in general, and then shows you how to do those things in a specific language. Take it easy, Lisp Gamer. Now, what book specifically? I don't know. I think I have not read C Primer, but can you tell me what it is about C Primer that you don't like? Is it this one here? Okay, like you're just tired of take care, Lisp Gamer. I won't be streaming on Wednesday, so but yeah. No, this looks like a well-rated book. So am I getting that you're just tired of reading and you want to make something? Is that what it is? Because that I understand. You know, when I started reading, the first book I ever read on programming was about Pascal programming. It wasn't C or C++, and like every chapter, at the end of each chapter, it had a section on like it had like a bunch of exercises, and I would do a lot of the exercises. And I remember, you know, at first I would do them and I was really into it, but then as I was progressing through the book, I started to get annoyed because I just wanted to get to the last chapter. Because the last chapter, up until the very end, it was all text-based, console-based programming with Pascal. But the last chapter was on Turbo. It was Turbo Pascal, and it was on Turbo's BGI library, which was BGI, the Borland Graphics Interface. This thing here, and Borland's it was just this library from Borland that allowed you to like enter into different modes, graphics modes, and start drawing lines and stuff. And man, I was so excited to get there. So at one point I kind of just started skipping ahead, and I sort of said, okay, I get it, I know enough, and I jumped to the last chapter and I started reading this one and immediately started designing like a game using this graphics library, and then the fun really began. So that's how it was for me. So I understand, how you're feeling. There's like a certain base that you need. You kind of have like no choice. You got to do the base. you know, it's hard to write anything real without at least getting all the basics out there. So I don't know at which level you're at, but you gotta, you know, understand the structure of a program, and obviously variables and conditions and functions and loops and all that stuff. You want to understand a little bit about object lifetime, you know, memory allocation and freeing, the heap, the stack, that kind of stuff. You know, you need to understand those things. But once you have like a decent grasp on those things, you can start trying or make a game or make, you know, I don't know what you want to do there, but for me it was about making games. Those are a lot of fun because you get a lot of immediate feedback, and you definitely learn a lot. And what happened for me, and it happens for most programmers, is when you begin your journey of actually writing code, the code that you write at the beginning, it's not going to be really good code, right? And you'll write it and it'll work. And then as you continue to write code and you continue to read and come back to it, and you'll learn a little bit more, you'll find that like your code will kind of progress in the same code base, and you'll have sections that kind of suck because you wrote them a few months ago, and the newer sections are better. And then you'll kind of go back and you'll fix the old stuff or not fix it, and you'll almost be able to tell how old your code is by the style or, you know, the idioms that you're using. You're like, oh yeah, I remember when I was writing one of my first games in C, and I had like this old piece of code where I did not know how to use structs, and so I had like arrays of ints and arrays of floats and arrays of bools for like all my characters. And then later on I learned about structs, and I started using structs and having arrays of structs, and so you could tell this like where I learned things and when I started using them. So you know, that's pretty natural. You're stuck on pointers, and the book is making pointers seem really dull. So pointers, I think, it's one of those things that trips up a lot of people. So if you're finding them a bit complicated, you're not alone. They seem to be one of those topics, right, where it's always tricky at first, and I think mostly the trickiness around pointers comes down to, I think a lot of the trickiness around pointer is just syntax. Like, unfortunately, this is C, right? This comes from C. The syntax around pointers is just atrocious. It's like as if they had only 3 characters that they could use, you know, asterisk, ampersand, and like parentheses, and they're like, you know, use that to do everything possible with pointers. And so yeah, I think that, you know, because of the syntax, it adds to the confusion. You know what I mean? I think once you cross that syntactic bridge and you just sort of absorb it and it becomes internalized, you don't really see it anymore. But the very fact that, you know, you've got this, you write your type, and then you write your asterisk, and then there's all like, where do you put it? And so you do this, right? That's P is a pointer to int. And of course, if you have an int, then, you know, P is, you can assign to P the address of A. So there's the ampersand, right? But then you have, you know, you can actually do something like this, and oh look, the asterisk has been reused to dereference P, right? So that's one of the first things where you have star being this asterisk being overloaded to mean 2 different things. Here it's for declaring a pointer, and here it's for dereferencing a pointer. So just that, I find, trips up a lot of people. Of course, ampersand is used for bitwise and as well as taking the address of something. And in C++, to add to confusion, it's also the reference. It's used for references if you attach it to a type, you know. So that's, yeah, you know. So learning C++ makes it even harder because you have to learn about ampersand being used in different contexts as well. Hey, Synchron. Let's see what Synchron says. Pointers make so much sense if you learn about memory. Learning pointers as a language feature makes 0 sense. And when you're learning about pointers, don't use references, which are awfully named. Very true. Yes, since you're learning C, you don't have to really deal with references, so that's kind of a good thing. But what Synchron is saying is very important. Yeah, pointers is really just another way of it's just another variable type, right? And I guess you understand this, but, you know, at the end of the day, just like how B is an integer, here p is just another variable that holds an address to an integer. And one interesting thing about pointers is in like the original C language, there were no pointers, and everything was, you know, there was one word size, right, which was like your int, and you would just store either a value or the address of a value into an int, and then you would be able to use it either, like you would either interpret it as a pointer or you would interpret it as a value, which actually made code difficult to understand in a way, because, you know, you didn't know if you were dealing with an address or a value, but at the same time it kind of obviated the fact that they were the same thing. You know, a pointer is just a variable that holds an address, right? That's the key. And later on they added the asterisk syntax to differentiate pointers from regular values. And then later on, in fact, they added even data types, because initially pointers were just like, I think you'd start, I don't know if it was void, but effectively all pointers were void. Like a pointer didn't have a type, it was just an address to something, and then you had to interpret it, you'd cast it to whatever it was supposed to be. But later on they said, no, let's strongly type the pointers, which was very, very helpful for, you know, writing correct code. And also for things like if you have a pointer like this and you say ++p, the compiler will be able to help you by advancing the pointer the size of an int, you know, things like that. So there's a lot of kind of history behind the pointer syntax and where it came from in C. And when you know that history, it can help a little bit to demystify where this comes from. And I actually learned that a long time ago when I read about, I think it was Ricci, who wrote like an article about the history of C, and it talked about BCPL, which was the language, the precursor to C, how it worked, and then what he took from it and brought to C. And it was kind of an eye-opener for me when I read it, like, I don't know, 15 years ago. It explained a lot of the weird syntax behind C, a lot of the mistakes. Like, you know, one of the interesting things that was written by, it's Brian Ricci, right? No, I get this one always wrong. It's Brian Kernighan, Dennis Ricci. So Dennis Ricci wrote, he writes this thing, yeah, Dennis, that's right, and Brian Kernighan. So he writes this thing about how they made a mistake, actually, when they were implementing C. In terms of operator precedence, and what the mistake was that, what was it again? I think it was asterisk has like lower priority than the equals. Is that what it is? I'm trying to remember. Hold on. It's like the reason why when you have, let's say this. Oh yeah, no, sorry. It's the dot. For, you know, if you have like a struct, that's it. You know, so let's say you have a struct foo, and you know it's got like a int bar in here, and then here you have, whoops. You know, you have some pointer to a foo, right? And you'd want to do, they wanted you to be able to dereference it and then access bar this way, right? But unfortunately, they made it so that the asterisk here, the dereference operator, had lower precedence than the dot operator. And this was like in the language and it was already being used, and they went, oh shit. They're like, that sucks. Because now everyone was forced to put parentheses around the star P, because otherwise the dot would apply to the pointer, right? Which of course wouldn't work, it would give a compile error, and this was dereferenced the result of this expression here, which is exactly how it works in C and C++. And so everyone's forced to do this. And so as a result, they went and added the arrow operator to fix this problem in the language. So that was something I learned by reading about the history of the language. That initially there was never a need really for the arrow operator, right? They would have just, if you think about it, like the number of characters you write, you know, this is 1 and 2, and that's just enough, you know? And it would have been just as clear if the precedence had been right. If this had been higher precedence than dot, then this would have been totally fine. But in the end, we ended up with this as a hack to fix the problem that was already there. So yeah, you know, that for me was really an eye-opener. Not necessarily saying that that's the way you should learn it, but maybe. It'd be nice if I could find that article. Dennis Ritchie. It might be this here. Yeah, I think this is it. It's called The Development of the C Language, written by Dennis M. Ritchie here. Let me paste that into chat if you guys are interested. So this was one thing I read, and there's a lot of stuff in here that's really interesting. I don't know if it's here that he talks about the asterisk stuff. Well, you need a project, you know, and if you want to be motivated, that's what I was saying earlier. Like I kept dreaming about this project I was going to work on. Here we go. Look. An accident of syntax contributed to the perceived complexity of the language. The indirection operator, spelled star in C, is syntactically a unary prefix operator, just as in BCPL and B. This works well in simple expressions, but in more complex cases, parentheses are required to direct the parsing. For example, to distinguish indirection through the value returned by a function from calling a function designated by a pointer, one writes star FP like this and star PF respectively. Is this the one? Well, this talks about some of the confusing syntax around the pointers. But this is not the one I was... Okay, no, sorry, I thought this was the part where it spoke about the arrow operator. Yeah, here he talks about the language changes during this period, especially around 1977, were largely focused on considerations of portability and type safety in an effort to cope with the problems we foresaw. C at the time was still manifested strong signs of its typeless origins. So you see, it used to be a typeless language. Pointers, for example, were barely distinguished from integral memory indices in early language manuals or extant code. The similarity of the arithmetic properties of character pointers and unsigned integers made it hard to resist the temptation to identify them. The unsigned types were added to make unsigned arithmetic available without confusing it with pointer manipulation. Similarly, the early language condoned assignments between integers and pointers, so it allowed assignments between integers and pointers, but this practice began to be discouraged. A notation for type conversions called casts was invented to specify type conversions more explicitly. Beguiled by the examples of PLI, early C did not tie structure pointers firmly to the structures they pointed to, and permitted programmers to write pointer access member almost without regard to the type of pointer. Such an expression was taken uncritically as a reference to a region of memory designated by the pointer, while the member name specified only an offset and a type. Okay, so again, it's not exactly that. So anyway, lots of juicy things in here. So if you're interested in C and how it became C, this is a good one. And then finally, there was one, I think it was Ritchie, about BCPL specifically. I don't know if it was this one. No. I'll try and find it. But it was really another interesting. Maybe it was Kernighan who wrote that one. Kernighan, sorry. It might have been this one. No. Anyway. So, ABD, what is it that you want to make? Like, what's your goal? Do you want to make a game? Do you want to write an emulator? Like, what is it that you're hoping to achieve? I mean, if it was me, I would start on something very simple. If you're interested in making a game, I'd say pick like a simple 2D game, you know, maybe Tetris, Blockout, you know, something nice and simple 2D, things you can implement where you focus on arrays and the logic isn't too difficult. So, you know, it's my opinion that emulators are not the easiest things to write. Definitely, I would not start by writing an emulator. I mean, there may be people out there who disagree, but, you know, I feel like because in order to write an emulator, you need to be comfortable implementing in a programming language another programming language in a way, right? You need to like implement an assembly, sort of like an assembly interpreter, if you will, right? It's not quite that, but along the same lines. And so you really need to understand the machine at a lower level. And I feel like unless you're coming from an engineering background where you do understand hardware and you know, you have a good grasp of computer engineering and hardware and architecture, that's probably not the best thing to start with. But if you're interested in making a game, pick a game that's really simple. You know, Tetris is a great example, like I said, or Blockout. These games where like you can represent most things as in arrays. Yeah, totally. Start with a simple 2D game, you know. And I would not use OpenGL or anything like that. I would take SDL and use the simple SDL window and like SDL surface stuff. They're nice and easy to get started. You can plot stuff. Exactly. What Mooball said is exactly right. You definitely need a project, you know. And like stick it up on GitHub and, you know, like get your friends to look at it and just that. Like, these things are motivating, right? Even and don't worry about how bad the code might look or anything like that, because, you know, we've all been there. Yes, exactly. Synchron is right. Reading, you know, you don't learn really by reading. You learn by writing. You know, you have to read just to get the main ideas, but they don't get cemented in your brain until you've actually struggled through and written the code yourself, debugged it, and then only then will you internalize it. Exactly. I'm just gonna say the same thing here, here, and here. Oops. So hopefully that'll help you, ABD. Don't give up, man. Programming is super fun, but it's the programming part that's fun. It's not so much the reading, you know. And then the thing with the reading is that it gets easier, right? Like once you've gotten the basics out and you've actually start really programming stuff, and then you go back to reading. Now you start reading more advanced concepts, and actually that reading is way more interesting than just the beginning, right? Than getting the base down. Because anyway, for me it was like that. As I advanced through my learning and my career, I would pick up more advanced programming books that talked about higher level things. Or let's say one of my favorite books when I was younger was this Andrei Alexandrescu's Modern C++ Design. And this was a book that really excited me when I read it, because it was just like this book here. Now it's kind of dated there, although I still think it's excellent. Look, a 2001 book. But this book, it was just like mind-blowing, right? He basically, the whole book is about template metaprogramming in C++, and by then I felt like I was decent at C++. But then when I read this book, it was like, what? I did major in computer science. Yeah, I studied computer science at university. But yeah, this book changed everything for C++. After this, template metaprogramming and policy-based design became a big thing. A lot of what's in C++ 11 was influenced by the work of Andrei Alexandrescu, and we still see it to this day. But the point is that once you get past the basics and you're actually productive in programming, these kinds of books are really much more exciting and interesting to read. I remember reading this and I couldn't wait to get home and try some of this crazy stuff, So yeah, just stick with it, get through the basics, start writing your game, and I'm sure you'll love it. So yeah, Will the Ninja, I did study computer science. I have a bachelor's degree in computer science. And in fact, I studied computer science and I did not do much hardware. And so I started working in video games because I always wanted to work in video games. And, my lack of knowledge in hardware pushed me to really learn as much as I could. So I started reading a lot about hardware and trying to understand what happens lower. I started trying to learn assembly programming. And actually writing emulators has been a really great way for someone who comes from a more software perspective to understand hardware, but without actually having to mess with the real thing, So it's kind of like a nice, easy way, I think, to get into hardware, at least from a software perspective. Let's just say when my emulator doesn't emulate a chip correctly, there is no boards that are being fried or sparks flying anywhere. Not unless I emulate that as well. So that's sort of what I mean by it's a good way to learn about hardware. So guys, it's 11:16 and I can feel my throat swelling up a little bit. So I think I'm gonna call it a night. Just go rest up a little bit. Like I said, I won't be able to stream on Wednesday. I have something else to do. But I'm sorry, Cinecron. I'll be back next week, same time, same day, and back on regular schedule again. So I do really try to stick to my schedule. I know I slip here and there. Mondays, Wednesdays when I try to stream, but things come up. So thanks again for watching and for chatting and all that. And hope to catch you guys next time. Take it easy.